So this one is chemistry classified paper, which is related to topic 5 questions, chemical energetics. And you may find some of the parts which are from other topics, as in chemistry. The topics are actually interrelated. So there are relation between the two topics as well. So you will find in this topic 5 of chemical energetics, some question might be from electrolysis, some are from the first topic. So in the first part, the energy level diagram shows the energy profile. So this one is topic 5 related to chemical energetics, and we'll do page 1 and 2. So complete the diagram by adding a formula. Like the energy level diagram shows the energy profile for reaction between zinc and sulfuric acid. So when zinc is reacting with sulfuric acid, so zinc plus sulfuric acid, what will be the product when acid is reacting with a metal? Salt and water. Sorry, salt and hydrogen, yeah. So because it's a sulfuric acid, so which salt it will form? It will form sulfate salt. So it will form a zinc sulfate. So zinc is +2 and sulfate is -2. So zinc sulfate will be ZnSO4, and there will be a hydrogen gas or bubbles will be there. So we have to complete a diagram by adding a formula of the products, including the state symbol. So the product will be zinc sulfate plus hydrogen. How to identify the state symbol of the salts? As the table is there, all nitrates are soluble, most chlorides except silver, mercury, and lead. Most sulfates are also soluble except barium, calcium, and lead. So what will the state of zinc sulfate? It will be aqueous. And what is the state of a hydrogen? Gas. So we'll say hydrogen gas. Draw an arrow on the diagram to represent the activation energy. This is a common mistake I found like students are making in this energy profile diagram. When they ask to draw an activation energy, they draw from the bottom, like anything at the bottom till the top. That's wrong. You activation energy is energy from reactant till the start of reaction. So you check the energy level of the reactant until the start of reaction. That is known as the activation energy. You can label that as EA. E is for energy and A is for activation. In this reaction is endothermic or exothermic? What kind of reaction is this? Which reaction this appear to be? Reactants have high energy and the product is having low energy. That's right. So this reaction is exothermic, not endothermic. Why? Because in exothermic, reactants have high energy and the product is having low energy. So which kind of reaction is this? This is an exothermic reaction. And reason for your choice, because the reactants have high energy or more energy than product. So in the energy profile diagram, if it's an exothermic reactants, reactants are always at the, if it's an exothermic, reactants are always at the top. And if it's an endothermic, reactants are always at the bottom. The reaction between zinc and dilute sulfuric acid can be catalyzed by adding an aqueous copper 2 sulfate on the diagram. Add the energy for a catalyzed reaction. So if you use a catalyst, what is the effect of the catalyst? Catalyst alter the rate of reaction by lowering the activation energy. So without a catalyst, if this was a high activation energy, with catalyst, the same reaction can happen or occur with a low activation energy. And here we don't have to write the name of a product in this case, as we already did, but I just mentioned. So we just have to complete to show that as we catalyze the reaction, the activation energy will be lower. In part E, student electrolyzed aqueous copper 2 sulfate using an apparatus. Carbon electrodes are there. So he's using a carbon electrode. The power supply is there. From the negative terminal, the electrons will move out, so majority of electrons will be here. This will be a cathode, and towards the positive terminal of a battery, it is attracted, so majority of the positive ions here, that will be anode. The electrolyte, the ions which electrolyte contain, it contain copper ion, it contains sulfate ion, it contains hydrogen ion and hydroxide ion. What will happen? Because it's a carbon electrode, so less reactive ion will move. So less reactive ion will move. Copper is less reactive, so copper will move towards cathode. So equation for copper is copper ion gain electron turned into copper atom, which will stick to the cathode and the cathode size will increase. For negative ion, sulfate, nitrate, carbonate never move, so hydroxide will move there. And whenever four hydroxide ions are moving there, they will give oxygen and it will give two water molecules plus 4E. And as a result, there will be bubbles seen at anode. So cathode copper will move, at anode hydroxide ion will move. Write an ionic half equation for a reaction at the negative electrode cathode, including the state symbol, a 3-mark question. So what you have a copper ion gains electron, turn into copper atom. What about the state of the ions? The ions are aqueous, so this will be aqueous. And what it turned into? It turned into copper solid. So 3 marks you will score just writing an equation using a state symbol. Describe what the student observed at negative electrode. So what we will observe at negative electrode as a copper is forming there, that's good. He will observe a shiny solid form. Or you can also say he will observe that the size of a cathode will increase. Give 2 other observations which student makes during this electrolysis. So what else other than this cathode? What he will observe? He will observe bubbles at anode. Don't say bubbles of oxygen. That is totally wrong because you are not in observation. By looking at the bubbles, you cannot tell which gas is there until unless you test out the gas. So there will be bubbles at anode. And what else? Because the amount of the copper ion in the solution or electrolyte is decreasing. So what he will observe? He will observe that the solution get paler. Or the color of the solution become lighter. What difference would the student observe at the positive electrode if aqueous copper 2 sulfate is replaced by concentrated aqueous copper 2 chloride? So now the same solution, the electrolyte has changed now, the same anode and cathode. The copper or a graphite anode and cathodes are used and the same power supply is there. We have a cathode, the negative terminal, and we have anode, the positive terminal. The solution contain copper ion, chloride ion, copper and hydrogen ion and hydroxide ion because it's aqueous. For positive ion, we'll check the reactivity. Copper is less reactive, so it will move there. As a result, copper will form. So same observation. But because it's a concentrated copper 2 chloride, so chloride ions are more and hydroxide ion are less. So if you have greater amount of a chloride ion, what will happen? Chloride ions are more, so they're attracted towards the cathode. And as a result, when 2 chloride ions are there, they will produce a chlorine gas and loses 2 electron. So we'll see bubbles, but this time what will be there? So because what difference would the student observe? You have to say difference in observation. So what is the appearance of a chlorine? Chlorine is a yellowish green gas. So as a result, we'll say we'll observe the yellowish green gas. So this will be the observation. So this was page 1 and 2 from classified paper, uh, topic 5.